This slide set is about medium access control. Medium access control's task is to provide rules for end systems that use a shared medium. There have to be more or less rules for it, because otherwise often data transmissions would interfere with each other. The figure on this slide gives an overview of multiplexing options which can be used for this purpose. In addition, it tries to map different technologies to the options. As you can see, for example, for GSM or LTE, it is not necessary just to use one way of multiplexing, because multiplexing methods can be combined. GSM and LTE, for instance, both use time division multiplexing, frequency division multiplexing, and space division multiplexing. One way of multiplexing is called space division multiplexing. Its idea is to separate transmissions that take place at the same time in space. In fixed networks, this simply means that systems use different cables. For wireless communication, the use of space division multiplexing is very relevant, in particular for mobile telecommunication networks, where only a limited set of frequencies is available. Let us assume that one base station uses one frequency to communicate with terminals within the mobile telecommunication cell. If you use the same frequency in a neighboring cell, interferences would happen. However, due to the limited number of frequencies available, you have to make use of the frequency in other cells. Otherwise, you cannot provide as much cells as needed to cover the whole country. So the frequency is used also in cells where the transmissions from other cells on the same frequency are that far away so that the signals do not interfere anymore. Another way of multiplexing is frequency division multiplexing. Here you assign different frequencies to different users so that the users can use the frequencies all the time. This is appropriate if the users continuously make use of the frequencies. This is, for instance, the case for radio or TV programs. Some radio stations even select names such as radio 90.3 MHz according to their frequency. However, this way of multiplexing is not very flexible. If a user does not have anything to send, then the bandwidth stays unused. An additional way of multiplexing is called code division multiplexing. Here the users can send all the time and on all frequencies. This is astonishing because all transmissions overlap. It works on the basis of individual codes which are assigned to the users. The codes are pseudo-random numbers. If a user wants to send a logical 1, then he sends his code, which for example comprises 32 bits. If the user wants to send a logical 0, then he sends the inverse of his code. The receiver can be tuned to the code in a way that it processes the signals according to a correlation function. All other transmissions are then some kind of background noise. Code division multiplexing requires no frequency planning and can assign many different codes. These codes allow for easy combination with forward error correction and encryption. However, it is quite complex and requires that signal strengths are often adapted. Otherwise, stronger signals would make it impossible to reliably receive weaker signals. The last general way of multiplexing is time division multiplexing. Its idea is that stations send at different times so that only one station uses the medium at one moment in time. Some kind of coordination or synchronization is needed so that each station knows when it can use the medium. There are several options on how time division multiplexing can be implemented, which is discussed in a specific video about this topic.